Welcome back to Titan Machine Tool. Today we're working on, well, in this video, let's rephrase, and in this video we're going to be doing side 2 of those wheel spaces, the tractor wheel spaces, because you know everybody who's got a tractor needs wheel spaces. So here we go, that's what we're doing. We got side 2 done. I got 3 of them done already. I'm going to let you watch me do number 4. Hopefully everything goes good. We did 3 already and there was no catastrophes, so fingers crossed we'll get through number 4 as well. But anyways, this is what we got going on here. We basically made a step, quarter inch turn step, 6-inch diameter, because that's what the wheels got. You need 6-inch for the wheel to mount right there, the hub diameter. 6-inch plus nothing minus, the print calls for 20, but I'm going minus 10. So we're looking at 5.990, give or take a little bit right there on that hub diameter for a 6-inch wheel to mount on with a quarter-inch turn step right there. Okay, so that's what we're gonna do. I got one in the machine already, last one in the machine right there. Okay, we'll hold it on the OD. Oh, I got a finished bore as well too. I showed you in video 1 that I did the counter bore. The back side over here, right? I showed you I did that, and I told you at the end of the video, I put a chamfer on that 5.5-inch through bore right there. You can see that chamfer right there. I did that when I was doing side 1, anticipating that I have to bore through from the other side to finish that 5.5-inch diameter through, plus 25 minus nothing. So when I did this side, I put that chamfer on it right there, so when I came through on the other side, there'd be no burr, so I wouldn't have to go back and deburr it. So that's where we're at. We're gonna run this down here. We're gonna run a roughing tool here. Basically, I just did a tool path and told it to repeat. I tried a couple different ways. This thing makes nasty chips, nasty. So anybody out there that's insert guru, that's gonna tell me what kind of insert I need to prohibit gigantic bird's nests from accumulating, because that's what I've been having problems with. The biggest problem is mitigating the chips. So I got my trusty old hook right there and I pull them away. So forewarning people, if the camera angles kind of suck, it's because I got to switch to my left hand and hold the camera with my left hand. All right, that might work. I'm holding it right now with my left hand, because I'm gonna have to reach in here and pull these chips out as it's running, because they are atrocious. I'll show you what we got happening here. We're collecting them in the barrel right there. Nasty, nasty chips. So what I did was, no matter what I did, I was having problems. I would have to stop the machine, pause the machine, feed hold, and turn the spindle off, and pick the chips out, and then turn the spindle back on, and resume the cut. So what I did was I essentially made a facing path. Instead of turning this way, instead of turning in the Z like this, repeating over and over again, I went with a facing path. I'm gonna plunge just like you're facing, like this. Shh, shh, shh. How do you like those sound effects? All right, so that's what I'm gonna do. But doing that, I was still getting unbelievably nasty stringy burrs. So instead of using a cycle, I had to do it by hand. I had to program one path whereby I go in 200 thousandths, I back up 10. I go in 200 thousandths, I back up 10. I go in 200 thousandths, I back up 10. That allows for the tool to separate from the material and the chip to break. And when the chip breaks, at least it's not one big giant continuous chip. They're terrible, terrible to deal with. This is still gonna be bad, but nonetheless, it's better. So here we go. Oh, helps when you put it in gear. Sorry, people. All right, machine's in gear. Yeah, so I loaded it up. All right, here's another thing too I want to show you. We're holding 9 5/8 inch diameter on the OD right there. And I got them jaws hanging out. Boys and girls, do not do this at home. I got them chuck jaws hanging way too far out. So do not do that. You see what I'm doing? Don't do what I'm doing. Don't hang them chuck jaws way out like that. I'm a professional risk taker here, so this is what we got happening. But anyways, I'm holding on the OD. I don't have a real tight grip because obviously so I'm holding on fairly lightly. So we kind of had to pussyfoot a little bit here, but I don't want to take all day, so yeah, you'll see. Here we go. All right, like I said, if I have to switch hands, it's because I got to get in there and control the chips, and we need better chip management. So anybody knows if my feed's wrong, I'm moving at, when I move in and cut, I'm moving at like 5 inches a minute at 185 RPMs, and I don't have constant surface speed. So the surface footage is gigantic when I'm out there at 9 5/8 inch diameter. As I move in to 6 inch, it doesn't become so extreme, but yeah, here we go. That's why the chips are coming off and changing color, because you know they're cooking. They're hot too. All right, so here we go. First thing the tool does is it takes a facing pass. And because I'm gonna be cutting air, I'm gonna put it in track. I'm gonna track right through this because I know this one's cutting nothing. I back the tool up a little bit. This is my rough facing tool. Rough face, rough turn. So let's see, this should be at 0. We may cut, we may not cut. Now we ain't cutting, so we're just gonna fly right off of that. So that tool's a little advanced in the Z plus, but that's good because it's a rougher, so I want. All right, so we'll put it in gear. Stop, CNC, run, go. Oh yeah, it backs away just for safety before it starts to tap. Here we go. We're cutting now. Woo. I'm gonna step away, I gotta get my safety glasses. Safety first. Sorry about that, people. All right, the chips are flying. This is gonna run a while. Well, that was cool. I could see the tool like a mirror in the face of the car. Yeah, see what I'm talking about here? These chips. Woo, baby. I gotta back up here. I'm gonna try to hold the camera on point and get these chips out of the way. When it reaches 6 inch 10/1000ths, it backs away 1/2 inch, so it gives some room for them nasty chips to come off. Ooh, fireworks. This guy's gonna rough this thing out. Man, them things are hot. Cooking. Tell me what the best insert is in order to be able to cut this stuff and not have these gigantic stringy chips. This would all be one giant nasty chip if I didn't have that backup. I essentially got a 10,000 incremental backup every 200 thousandths forward just to break. Yeah, just to separate from the material and break the chip. I struggled with the first one a little bit, trying all different tool paths, cycles, and everything else in order to. I want to be able to walk away from it, but that ain't happening. Not with this one. Yes, I'm going to ask again, tell me what kind of insert I should be using on this. This is hot rolled steel, but just in general. Oh man, that was landing in my hair. My hair's going to catch on fire. I'm going to take a step back. I can smell burning hair. Take a step back. Zoom me in a little. So that's what is that? The CNMG? Yeah, that's what I'm using right now. CNMG 431. I don't know what the grade is. Wow, that chip just bounced off the camera. I'm gonna need a new camera after this video. Phone, I should say. See, I'm getting a good chip separation now. See, they're all short little pieces. Before it was like one giant continuous. You're trying to get me. Look, you can see a mirror on the. Oh, that's cool. I can see the tool like a mirror in the face of the cut. So cool. Hot chips. Something shirt on. Ah. Sorry. Damn. Fire. Haraka. I was doing sorry. Try to stay on point here. These chips are flying at me like hot fireworks. Chips coming off nice, I guess. Let's see. Sorry, my viewers. Watch out. Pick these up and recycle them. Well, it's going to be a long video. Yes, if I was doing a bunch of them, I could probably walk away. These chips now at this spot are doing pretty good. They're breaking off and flaring. But when they wrap around the tool, one big continuous chip, oh, what a mess that is. And then it tries to drag it back through. I mean, you could literally cause the part to come flying out of the chuck if it drag that big giant bird's nest back through where there was no space. So the incremental backup move seems to work because nothing else was letting me break that chip. I know I'm redundant here, but what the hell else am I going to talk about? The tools just keep doing the same thing over and over again, so I can just shut up and say nothing. Take my word for it. This shit's hot. Like I said, it goes in, backs up, goes in, backs up, goes in, backs up, goes in, backs up, and then it goes, we're finishing at 5.990. So that plunges in like that to 6" 10 thousandths. Then it backs up that 10 thousandths to separate, and then moves to Z plus 500 to get away from the part, and rinse and repeat, start the cycle over again. Chips are coming off with some velocity too. If I knew the chuck had a better grip on it and the jaws weren't hanging out so far, I probably could do it in less passes, but it's working. Here we go. All roughed out. Rough, rough, rough. Got some burrs there. Some chippies hanging on. Chippies hanging on. Blow this stuff away. Now we're gonna switch tools. Sorry for the fast change of view. I'm gonna give you motion sickness. Hope you don't have to get vertigo. So we're changing to a different tool here. That tool's taking such a beating, I don't want to really finish with that tool, so I'm taking a pounding. All right, so we're gonna finish with a CCMT, right? Yeah, that's a CCMT right there. We're gonna use that one to finish. But the tool nose radius on all of these tools is 15 thousandths, so I got tool nose radius compensation in the machine, so I just put it in the geometry page, 15 thousandths tool nose radius, and it compensates. All right, so it's calling for tool 2. Load tool 2, there it is. We're running everything at the same RPMs here. Actually, let's see, this is gonna come off. Yeah, pick that off. Start her up, go. It makes a funny move here because I'm running a cycle program and it usually wants to see multiple cuts, but I'm telling it just take one cut. So it makes a funny approach. So that's essentially a semi-finished pass right there. Obstructing the view. That's what I was saying about my left hand. You have a hard time seeing. That's the semi-finished pass right there. Takes it all off, goes back. Facing at Z0. 30 thousandths chamfer. Finish turn 5.990. 3 thousandths off the back face. You can program that amount in the first line of the cycle program. You tell it how much you want to leave on the finished cut. If you use the same tool, what's the tool? Tool 1, say, for roughing, tool 2 for finishing, you tell it that. How fast you want the finish feed rate, how fast you want the roughing feed rate. So that's all set up on the first line of the cycle program. Sorry for the camera movement. Boom, that's that. Now I would measure it, and I will measure it, sorry. I will measure it when I'm done the video, but we're already 20 minutes in, so we're just gonna finish bore now. Tool 3, boring bar. It's tool 3, it's tool 4, sorry. My tool geometry, I programmed it as tool 4. Okay, so load tool 4. Tool 4. Here we go. All right. Go. So it's gonna rough a couple passes, four passes, I think. It takes 2 ID passes, roughs the chamfer. I got a 30 thousandths chamfer in the front, semi-finished pass, and then finished pass. And when I program for boring, I usually essentially face at Z0 across the part, because I'm always going to have some sort of chamfer or radius on the front edge of the bore. So you'll see that tool come out and go to like 6.250 diameter. 6.250, then it goes to Z0 and it faces across Z0. You see it's just barely touching right there. And then it's going to do the 30 thousandths chamfer. Now it's going to finish bore the ID diameter at, what is that, 5.515. Yeah, 5.515. And that's it. She's done. All right, so that's it. Wheel spacer. Got a video showing you the turning the first operation, side 1. This is the video turning operation for side 2. Finish bore through, 5.5 plus 15 thousandths clearance. 6-inch mounting hub diameter minus 10 thousandths, 5.990. And we got a 9 5/8 OD, but that was water jet cut. So we cut the clean, that's all. It pretty much cleaned all the way around. There's only like one spot that's right there. The remnant telltale mark, witness mark from the water jet right there. Most of it cleaned up. All right, so that's it. That's what we've got going on here today. One of the things going on today here at Titan Machine Tool. It's a very long video, 22 minutes plus, but thank you for watching. Yep, fat finger. Thank you for watching. Titan Machine Tool signing off. Over and out.